Chapter 5, Question 7. Calculate the fluid GM of the vessel. So the first thing we need to do is to calculate the ballast that's on board. And this is going to create a free surface effect because it's only a half-filled tank. So your ballast is your length times your breadth times the height, and that's the height of the fluid in the tank, times the density of the water. So they tell us that the length is 14 meters, the breadth is 10 meters. The tank is a 5-meter high tank, but it's half full, so therefore it's 2.5 meters times the density of seawater, 1.025. So our ballast is 358.75 tons. So now we need to calculate the kg of the vessel. So it's easiest to do this in a table format. In the question, they told us that the rig displacement is 75,000 tons, has a kg of 7.8 meters. So you multiply these together and you get a vertical moment of 585,000 ton meters. Now the ballast has been added, so put a plus sign in front of this. So that's 358.75 tons. And the center of gravity of the ballast is going to be at half the height of the actual fluid in the tank, so it's 1.25 meters. You multiply these together and you get a vertical moment for the ballast of 448.44 ton meters. So you add up the weight column and you get 75,358.75 tons. You add up the vertical moment column. You get 585,448.44 ton meters. So now to get your kg, it's your vertical moment divided by your total weight. So your vertical moment is 585,448.44 ton meters. Divide this by the new displacement, which is 75,358.75 tons. You get a kg of 7.77 meters. So now we need to calculate the shift of the center of gravity due to the free surface effect of the fluid in this particular tank. So we're going to take the dimensions of the tank, so that's your length times your breadth cubed, times the density of the ballast water, which is salt water, so 1.025, divided by 12 times the volume, times the density of the water that the vessel is floating in, again is salt water, so 1.025. So the length of the tank is 14 meters. The breadth is 10 meters, so 10 cubed. Divided by 12 times, now we calculated the new displacement as being 75,358.75 tons. To convert that to volume, you're going to divide it by the displacement of the salt water, which is 1.025. The ballast water again is 1.025, and the vessel is floating in salt water of 1.025. So when you calculate this out, you're going to get a shift of the center of gravity due to the free surface of this tank of 0.0159 meters. Now to get the GM fluid, you have to calculate the kg fluid first. So the formula for this is your kg plus the shift of the center of gravity due to the free surface effect. So this is 7.77 meters for your kg. We calculated g to gv to be 0.0159 meters, so we add these together and we get 7.79 meters. That's your kg fluid. So now to calculate your GM fluid, it's going to be your Km minus your Kg fluid. Your Km is 9.2 meters. We calculated the Kg fluid to be 7.79 meters. So we subtract these and we get a GM, and this is your fluid GM, of 1.41 meters.